Hey guys, we are down to the last few days of school. Believe it or not, we're down to the single digits now. So this is our last week of real math stuff, and then next week we're going to do something fun. So this is it. This is the end. And remember, we're ahead of everybody. So this is just awesome practice for you guys to get you set up in just a couple steps of ahead of everybody else when you hit seventh grade next year. All right, so we're talking about surface area with prisms and prism pyramids with and without nets. Surface area is the total area of the surface of a solid figure. So for instance, when I look at this shape, I'm not just talking about the area of this side only, I'm talking about all of the sides. So I want to think about this like if I had wrapping paper and I wanted to cover that whole entire shape, how much wrapping paper would I need to cover it all? And then a net, of course, is what we were talking about last week. And that's when we take that shape and we unfold it into a flat 2D figure to see what it looks like unfolded. Of course, when we put it back together, it looks like this guy here, and the net is this 2D shape. All right, so finding the surface area of a prism, this looks super overwhelming, but it's not. You guys know exactly how to do this. We did it when we were just determining how to do area of composite figures. In other words, it's not just a square, it's not just a rectangle, it's not just a triangle, but it's all of these shapes that are mashed together, like a square with a triangle sitting on top of it looks like a house. We could figure out the surface area by figuring out the square that's on the bottom and then the triangle on the top, which is called a composite figure when it's more than one shape that are put together. So that's surface area. All you're doing is figuring out what is the net of that shape, and let me figure out the area for each section of that shape. And then when I add them all together, I have a surface area. So here's an example of what looks like a rectangular prism. If we fold it all back up, we would get a rectangular prism. And when it's unfolded into the net, we have all of these sections that we would solve for the area. This is, they are all rectangles, so the formula would be base times height or length times width. You find the area for each one, add them up, and you get a grand total. I hope you guys are using calculators. I've been giving you permission for a long, long time. All right, another method for figuring out the area of a prism is not to try to figure out what the net is, but instead, if you have the ability to look at shapes like this and be able to visualize it as a 3D shape, then you can go ahead and solve it this way. So on this shape, we have a rectangular prism again. The front side and the back side back here would have the exact same dimensions. And then the sides, this side and this side that's across from each other would have the exact same dimensions. And then the top and the bottom would have the exact same dimensions. So you have, here is the front dimensions. Um, Whoops, let me go back. Here's the front dimensions, the side dimensions, the top dimensions. You would multiply those times 2. So notice that the front one, the dimensions would be 12 by 3. 12 times 3 is 36, but there are 2 of them because the front and the back have the same dimensions. So you would take 36 times 2. The sides would have the same dimensions. They are 4 by 3. So that's 12, but there's 2 of them, this side and this side, 1, 2. So 12 times 2 is 24. And then the top, again, the top and the bottom have the same dimensions. The top is a 12 by 4, which is 48, and there's 2 of them. The top one is 48, the bottom one is 48. So there's 2 of them, it's 96. You add these all together and you get the total square units, 192. All right, so finding the surface area of a pyramid is no different than what we just did. In this one, though, we have triangles because pyramids have triangular sides. So we are looking at this shape, essentially, right? Comes to a point, and we're going to have to figure out 5 sides because we have the base, which is in this particular one, a 6 by 6 square. So the base is 6 times 6, there's 36. And then we have 4 equilateral triangles, meaning 4 triangles that have the exact same measurements. Remember that for the area of a triangle, the formula is half the base times the height. It says that the base is 6 and the height is 5. So we could take 6 times 5, which is 30, and divide that by 2 because we want half of the base and the height. So half of 30 is 15, and we have 4 triangles that measure 15 units, square units. So 15 times 4, each triangle, there are 4 of them, is 60. So we take 60 plus the base, which is 36, and we get 96 square feet. You could figure this out by kind of visualizing it as a 3D object, or if you would prefer to write the dimensions out on a net, you can also do that too, whichever one seems easiest for you. All right, I would like you guys to get out your workbook. We're going to do just a little bit more practice, and then I'm going to have you do a couple practice problems on your own, and that will be it for surface area this week. Okay, I would like you guys to go to page 426 in your workbook, and we're going to do just a couple of practice problems. So again, I'm on page 426. Hit pause if you need to get your workbook. Problem number 5, let's start here. So it says find the surface area of each prism. Well, we have essentially 3 math problems. This top piece and the bottom piece, I hope you guys can visualize and see what I'm drawing here. The top and bottom have the exact same dimensions, okay? And it's length times width. So we have a length of 10 times 2. So it's a length of 10 and, oops, I take that back, and a width of 5. Sorry, that's 5. So 10 and 5. So 10 times 5 equals 50. But there are 2 of them. So this top one is 50 and this bottom one is 50. So that's times 2 because there are two boxes that have that dimension. So that equals 100. Let's do the little end pieces right here. So we have one here and we have one here. The dimensions of those are 5 by 2. So 5 by 2 equals 10, and there are 2 of them. So this one is 10 and this one is 10. So we're going to multiply that by 2. So that's 20. So I have 100, I have 20. I have one more math problem to do. I'm going to do the front. That's this shape here. I know it's hard to see. And the back rectangle that's back here. Okay. And this one is 10 by, how tall is this? 2. 10 by 2. So that is 20. And there are 2 of them, the front piece and the back piece. So that equals 20 times 2 is 40. And now we just added together 100 plus 20 is 120 plus 40 more is 160. So it equals 160 square feet is our total. Okay, let's shoot down here to number 6 and we're going to try this again. This one is going to be way easier because every single dimension that's listed here is 7. That means all of these sides are congruent or equal. It is an equilateral shape. And then what you should know is that this is a cube, right? Because only cubes have every single dimension is the same. So how many sides does this prism have? It's got a front, a back, a front, a side, a back, and another side, and then a top and a bottom. So think about it like, grab one here, like this cube, okay? It's got 1, 2, 3, 4, 5, 6. It's got 6 sides to it. So we have 6 sides that have the exact same dimension, and the dimensions are 7 by 7. So 7 times 7 equals, think about it, 49. And now we have 6 squares that have a measurement of 49. So we're going to do 49 times 6, yes, you may use your calculator. I'm going to do it old school here. So 9 times 6 is 54. Carry the 5. 6 times 4 is 24. Plus 5 more is 29. So we get 294 centimeters squared as our grand total. All right, hope you're following along with me on that. I'm going to include a link to Khan Academy to help you find surface area too. Maybe you'll hear a different explanation. And if that's more helpful to you, then that's awesome. Whatever works for you is fine with me. All right, let's look at number 7 and then we'll do some practice. So we have a triangular prism here, meaning that it does not come to a point like a pyramid. It is a prism. We have formulas for triangles and rectangles in this problem. So I have 2 triangles that are going to have the same dimensions, and I am going to have 3 rectangles, the front, the back, and the bottom piece that it's sitting on. So there's going to be 2 of these and 3, sorry, you can't really see that, the 2, and 3 of those. All right, let's look at the triangle first. So it has a base of 2 and a height of 2, and the formula for triangle is half of base times height. So half of the base times the height, 2 times 2 is 4. So half of that, half of 4 equals 2. But there are 2 triangles. So we're going to have to multiply it by 2. So the triangles equal 4. And then for the rectangle, it's just base times height. The base is 3, right? This is 3. So it's 3 times 2.8. And let's bust out our calculators for this. We'll use them this time. And I'll turn this way down so you guys can see my calculator too, in case you don't have one. Let's see if you can see that. All right, so we've got 3 times 2.8, which is 8.4. Sorry, I'm too high up there. 8.4. And we have 3. We said we have 3 rectangles with that measurement. So we're going to multiply this times 3, and we get a total of 25.2. So the rectangles equal 25.2. And we're just going to go ahead and add that together. So 25.2 plus the triangles, which equaled 4. And we get a total of 29.2. Our unit of measurement is meters. So meters squared. Okay. Hope you guys got that. If not, check out that Khan Academy link that I'm going to share with you. If you do get it and you just want to give it a whirl and see if you got it, I would like for you to do problems 8, 9, and 10. I'll have a link in Canvas for you to upload your answers. I know you guys can do it. Think of how much your brains and your neurons are growing right now. It's so good for you for next year. All right, give it your all because this is your last real lesson as a 6th grade math student. I'll talk to you again soon.